All right, so we're going to do the next little part of 2-3. I think it's going to take 2-3 is fairly long lessons, so it's going to take us a few days to do this. So this is our second day. So let's talk about what's right in front of you right here. Okay, the slope-intercept form. I think we've already discussed this, but we haven't like officially taught it, I don't think, yet. But you've known this from before. You knew it from geometry. Probably knew it from Algebra 1. But what is the slope-intercept form? If we were going to write it in terms of y equals mx plus b, correct? All right, so that's a weird m. Let's make that look a little better. mx plus b. All right, so that is the slope-intercept form. What are the other two forms that we've learned? Do you remember the first form? Point slope. Okay, so what was point slope? Y what? Minus y1 equals m times x minus x1. Just put it right there. All right, that was the point slope form. Then, did we talk about the general form? Yeah, yesterday. Yeah, yesterday we talked about it, I think, because you weren't here yesterday. That's why you didn't know. All right, so it's ax plus by equals c. So this is the general form. This is the third form. I believe this is the only three forms that we're going to learn for an equation of a line. So these are slope-intercept form, point slope form, general form of the what? What do we call this? An equation. Just said it a second ago. What? It's just a letter. But we can find a couple things. We can find the slope and the y-intercept by doing a few things to this. Do you remember that? What do we call this though? Equation of a what? Of a line. Of a line. All right. So this is an equation of a line. Three different ones. Three different equations of a line. Different forms. Slope-intercept, point slope, general form. Okay. We're going to talk about the slope-intercept form today. So they don't say much about it. They just go right into an example. But I will mention a couple of things. Probably already know about this. I've probably already talked about this. But we all know what the m is. What is the m? That's the slope. Okay, and what is the b? It's the y-intercept. Okay, it's where it crosses the y-axis. So it's a line. Okay, this represents a line. All right, goes like this, however you want to look at it. But wherever it crosses the y-axis, that's what this point is right here. Okay, this right here is the slope. So if I pick any 2 points on my line and I do a rise and a run, that's what the slope's going to be. Okay, so those are the two things that are important, and that's why they call it the slope-intercept form. Okay, you don't have to be super creative. It's pretty much straightforward what it means. It gives you a slope and it gives you an intercept. Not just any intercept, but it's the what? It's the y-intercept. That's correct. Okay? All right, enough of that. Let's now do an example. What's that? You had a question? Alex.
So why is it that are there none that use x-intercept?
There's no like particular equation that uses the x-intercept, I don't believe, but there is a way to find the x-intercept. Okay, we're not going to talk about that right now, but that's another day. Rise over run is a slope, correct? All right, so let's do example 3. Here's what it says. It says use the slope-intercept form. All right, that makes sense because that's what we're studying in this little part of this lesson. So use the slope-intercept form, okay, to write an equation of a line with, and they tell you a couple of things. They tell you the slope. I'm not going to write out the whole thing, just waste of time. Use the slope-intercept form to write an equation of a line with a slope of 4 and passes through, I'll write that part out. It passes through, and they'll give you a point, and this point is 5, 9. So what in the world are they asking? Well, let's just do a little example. Seems like we did this. I don't know. Did we do this? I don't know. Maybe it's because we've done a lot of this in my geometry classes, so maybe I'm just thinking of that. They all run together after a while, so I can't remember what period or anything. Why doesn't that grab? I'll just move it like that. Okay. Um, so what's going on? All right. I mean, you could sit here and memorize how to use the formula, blah, blah, blah. But if you don't really know what's going on behind the scenes, it's kind of worthless. So I like to know what's really going on. So you don't have to graph this, okay? To do this problem, you do not have to graph it. I'm just doing this to illustrate what's happening here. Does that make sense? Just to show you what's happening. So 5, 9. So I don't even know if I have 9 places on here. 1, 2, 3, 4, 5 right here, and then 9. I think it goes up 8. 1, 2, 3, 4, 5, 6, 7, 8. 9 would be what? About right there? Okay, there's 5, 9. And then it says it has a slope of 4. So what I'm going to do is I'm going to start at my point that they give me, and I'm going to do a slope of 4. So I'm not going to go up and over because I don't have any more graph over there. So what am I going to do? I'm going to go down, right? Since the slope is 4, what can I do? I can go down 4 and then what? To the left one, right? And that'll give me a positive 4 slope. So 1, 2, 3, 4 right there. That's still a positive slope, isn't it? I just went down and to the left, all right? And so if I connect them, this may be off just a little bit. It may not be perfectly accurate, but it'll be pretty close. The graph should have been a little bit bigger. All right, so that's the line that we're trying to find the equation of. Trying to find the equation of this line. The equation of a line is just so that when I describe a line for you, I'm not going to sit here and say, well, go over 5, 9 and do a slope of 4. I would say y equals whatever x plus whatever. Okay, that's how I would describe it to you. And that would be the slope-intercept form. So what I'm going to do is I'm going to use y equals mx plus b. Now, I'm going to show you something. With y equals mx plus b, this is a point on the line. Do you remember with that point slope, we put that point in for x1 and y1? On this one, I don't really have an x1 and y1, but I do have a what? An x and what? A y. So this x and y, listen very carefully. It took me a while. I was probably well into college when I think when I first, somebody explained this to me, I'm like, oh, I never knew that. So anyway, this could be one of those situations. This x and this y right here represent any point on this line. So if I knew another point, let's say I knew that point right there, I could put that x in and I could put that y in, and it's going to satisfy that equation. So, but do I know a point already? Do I know at least one point on this line? Yeah, what is it? It's 5, 9, right. So 5 is the x and the 9 is the y. So what I'm going to do, since that x and y represents any point on a line, what could I put in? What numbers could I put in for x and y in here? 5 and 9. Very good. Okay, what else could I plug into this equation? What else do I know in this equation? The slope. Right, I know the slope, so I could put in that. So I know an x, I know a y, I know a slope. So what could I find then? I could find the y-intercept, the b. Does that make sense? Because I know 3 things out of the 4. Because I got 4 things. I got y, m, x, b. That's 4 things. I know 3 of them. I know the x from right here. I know the y right here. And then I know the slope because they gave it to me. So I'm going to put it all in here and then find the y-intercept. So the y-intercept's down here somewhere. I don't know exactly where it is because my graph doesn't go that far. But it's going to be negative more than 8, right? Maybe 10 or something. I'm not really sure. Okay, so let's put it in and see. So what am I going to put in for the y? I've said this like 5 times already. I'm going to put the 9 in, equals the m, which is easy. That's the 4. What is that m and that x doing to each other? They're multiplying, right? So times what? 5, and then plus what? B. And now I can just do a little arithmetic, very, very little, and then I can solve for b. So let's do that. A couple steps and we'll be done. So 9 equals what? 20 plus b. How do I get b by itself? Subtract 20, and then what's b equal to? Negative 11. What does that mean? Now this is why I drew the graph. This is basically why I drew the graph. What does that b mean to us? That means it's the what? It's the y-intercept. So it crosses. Does that look like it could be a negative 11? Yeah, absolutely. Okay. So I just didn't have enough graph for it. So yeah, that's absolutely where that should be. So the problem is, though, is not just to find the y-intercept. What am I trying to find? I'm trying to, it says, use the slope-intercept form to find the what? equation of a line. All right, that's what I'm trying to do here. So let's write the equation of a line. So I'm going to write y equals m. What's my m though? I know it. 4. And then I'm just going to write an x. And then I'm going to put whatever the y-intercept is, which is minus 11. So this is what we're looking for right there. That's what we're looking for. So I use the slope-intercept form in order to find the y-intercept because they told me a point, they told me the slope, right? And then that allows me to find the y-intercept. Now, this particular problem says use the slope-intercept form to find all that stuff, okay? But we also could do it another way. What's one of our other forms that we had? It's a fairly usable form. This point slope form, right? So if it were me and they didn't tell me that I had to find the slope like a particular way, but they did on this problem. They said use the slope-intercept form. But I could find it another way. Tell you what, let's just separate this. Let's find it another way. Another way. And let's see if we get the same thing. All right? They gave me a point, 5, 9. They gave me a slope, 4. What form of an equation of a line do we know that we can use a point and a slope? Point slope form, okay? Exactly right. So let's see if we can put it in the point slope form. I've already written it down up top there, so I'm just going to fill it in. So it's y minus y1. What's our y1 here? It's 9 equals m, which is 4, times x minus x1. What's our x1 here? It's 5. Okay? This is actually, I think, a lot easier. But what did the instructions say, though, on this one? They said use the slope-intercept form. So I think that's important because there's a lot of times you might want to solve for the y-intercept. All right? And that's a nice, easy way to do it. But this is easier. This is easier. So what do we do here? I got to solve for y. I want to make it look like y equals mx plus b now. All right? Even though I started with the point slope form, I'm going to end up with a slope-intercept form. So what's the first step I'm going to do here? Am I going to get rid of that 9 right off the bat? No, not sure. What is it? What's the first thing you want to do here? Distribute, thank you. We're going to distribute. So y minus 9 equals, right? We're going to distribute that thing. So let's do it. That's 4x, what? Minus 20. See any numbers that look familiar? Yeah, absolutely. All right, so what can I do now? Now I can get rid of that 9. So I add a 9 to both sides. And guess what? It comes out to the exact same thing as we got earlier. Right there. All right, so those comes out to the same exact thing. Which way did you like better? Yeah, I kind of like this one better, don't you? All right, but this still works. And that's what they're trying to show you. All right, and that means that this x and y, you have to understand that it represents any point on a line. Well, they tell me one point on a line, so let's use that one point that I know. So we stick in the x and the y for that, solve for b, and you're good to go. But this is another way to do it. This is just using the point slope form, and that's why we have the point slope form, is for situations like this. When they give you one point and one slope, then it makes it really simple to find the equation of the line. Make sense? Yeah, that's not too hard. Let's do a little bit more. Let's see what page I'm on. All right, this time we're going to graph, right? We already know how to graph. Oh, I got rid of that thing. But I'm going to do it again. I don't know if they've officially taught you how to graph. Did they, or did I just assume that you already knew how to do that? I can't remember. I can't remember anything. Yeah, you would think that... What happened here? I did something weird. Oops. Yeah, I did that. Let's start again. I don't know why they separated. There we go. Yeah. All right, so here we go. What we're going to do is we're going to graph. And why did it... Oh, I know why. Okay. All right, we are going to graph this right here. You ready? This really should not take much discussion. You should probably already know how to do this. So let's just change this to a different color. All right. So here it is. This is what we're trying to graph. Here's your graph paper. All right. On that other one that I did with the graph, you didn't have to graph that one. But on this one, you do, because that's what the problem says, is to graph it. What's the first thing that we're going to plot here on this graph? The y-intercept, absolutely, okay? Because it's a point. It's just a point on the y-axis. So here's the y-axis. So you just look on the y-axis for -2. Where's -2? It's right here. Just put a little dot. It's as easy as that. What's that? Just give me a pass. All right. Now, from there, there's only one more thing to do. What is that? That's it, okay? But you want to make sure that you start from that y-intercept, okay? I've had a lot of people, not a lot, I've had some people. Let me grab my, oops, that's right, I'll use this. Break my streak of, oh no, I did have a black one in there. Oh well. So, what was I saying? Oh, start from the y-intercept, okay? I've had people start from the origin. Don't do that, okay? You plot the y-intercept first. In fact, in my notes, I even, the very first thing when we graph stuff is you plot, oops, not plot, or not ploy, plot the y-intercept, okay? So that's the first thing you do, okay? The second thing, you, I put this, from the y-intercept, do a rise and run, which is the slope. Oops, and run. All right, and then the third thing, once you get that, you'll have a second point once you do number 2, and then you just connect the points. Connect the points. All right, so there's my little steps right there. If you want to write it down, if it helps you, feel free. If you already know how to do this, it's no big deal. You don't have to write that down. So we plot the y-intercept right there. From the y-intercept, what do? We rise and run. How far do we rise? How far do we run? Well, that all determines on what that number is. So I start here, rise 4, run 3. So I'm going to rise 4. Now look, here's another thing that I've seen students do. I'm trying to show you what other people do so you don't make the same mistakes. I've seen some people say, oh, that's 4, so that means I go up to 4. Does that mean I go up to the point 4? No, it means I just count up 4 places. All right, so I'm here and I count up 4 places. 1, 2, 3, 4. Don't put a dot yet. We still have to run. So how far do we run? 3. So we go to the right 3 places. 1, 2, 3. And then I put a point right there. I got my 2 dots. Don't just leave it as 2 dots. What are you going to do? Connect them. And look, here's something else that some people do. Some people just connect from dot to dot and they make like a little line segment. They start here and they end there. Don't do this because it's not a line segment. It's a what? It's a line and it keeps on going. So extend it in both directions, all right? It just looks a lot better. It's just what teachers are going to want. Okay. And there's your line right there. You've graphed it. That's how you graph it, all right? That'll be on a quiz, be on a test. I'll say graph this thing right here, all right? Let's do another one. I didn't plan to do this, but let's just do this anyway. What if I said graph y equals -3, x plus 1? What if I asked you to graph that? What's the first thing I'm going to plot? +1 on the y-axis. So you put a dot right there. Now we're going to do the slope. So what is -3 though? I need a rise and a run. What's the run here? It's a 1. That's right. I can just put that over 1. There's my rise, -3. There's my run, +1. So I'm going to rise -3. 1, 2, 3. I'm going to run 1 right there. Put a dot, connect them, and I got my graph. It's pretty easy. I think you'd agree, wouldn't you? I'm not just saying that because I'm the teacher. I've been accused of that many times. Mr. Hammer, you always say it's easy. Well, you're the teacher. Of course it's easy. No, it's not true. I think this is easy no matter who you are. Don't you? Yeah, I think so. We've got one more thing to do. And let's just do it right now. This is a little different, but it still has a lot to do with what we've been talking about. So let's go back to white. And this is example 4. Example 4. Let's see. It says find the slope and the y-intercept. Okay, find the slope. I'll put m and the y-intercept. I guess I could put b, but I'm going to write it out. Y-intercept of this line. Equals -3 parentheses y plus 5. All right. Now, just looking at it right now, are you able to pick out the slope? Am I able to just look at this and say, oh, that's the slope? No. Could I look at it and say, oh, that's the y-intercept? No. I need it to be in a certain form. If I could get it into a certain form, then I could look at it and say, oh yeah, that's the slope, that's the y-intercept. But it's not in that form yet. What form do I want to put it in? Y equals mx plus b, which is the what? What's the name of it? Slope-intercept form. So that's what I want to do. I want to make it look like this. Okay? So basically, what am I going to do here? I'm just going to solve for what? Solve for y. That's right. Okay? Get y by itself. All right? That's all I'm trying to do. So what's the first step? We've done this step once already today. What's the first step I'm going to do? Just algebra. Distribute. Distribute that, and in the same step, we'll go ahead and distribute this. Everybody sees that part, right? So let's do it. What do we get? 2x minus 6 equals -3y minus 15. Did you get the minus part? Because you got to distribute the negative through there as well. Again, what are we trying to do here? We're trying to solve for something. What are we trying to solve for? We got two variables. I got a y and I got an x. Which one of those am I trying to solve for? I'm trying to find the y, okay? I'm trying to find y. So let's get y by itself. It's over here on the right-hand side. It's fine. It can be on the right-hand side. Let's just keep it there for a little bit. So what am I going to get rid of? What am I going to get rid of if I want to get y by itself? The -15. How do I get rid of the -15? I add it. So I add a 15 to this side. I come over to the other side, and I add a 15 over here. Don't add it to the 2x because the 2x has an x with it, right? I can only add just the regular numbers. We call them constants. Okay, if it's just a regular old number with no variable next to it, it's a constant. So we just add the constants together. All right, that thing canceled out. So what do we have here? I got 2x. What's that going to be? 9 equals -3y. Everybody good? One more step, and you basically have y by itself. All right? So again, I'm not going to add it. What is that -3 doing to the y right now? It's multiplying. So what's the opposite of multiplying? Dividing. That's right. Okay, so we don't add a 3 because adding a 3 is not going to get rid of that 3 because that 3 is being multiplied. We have to get rid of it by always doing the opposite. The opposite is division. So we divide by a -3. Now, over here on the other side, we have to divide. We don't just divide the 9 by a -3. We divide everything by a -3. So we divide that by a -3. We divide that by a -3. All right, what happens over here? The -3's cancel out. So what are you left with? Just a y. You okay if I just move it to the left now? So, because this equals y is the same as y equals this, okay? So y equals, what's this? Well, it's the same as -2/3 x, isn't it? It's just, look, it's this fraction, the -2/3, it's being multiplied by the x. So I can just write it a little neater, a little nicer, just like this. Right? And then we got to divide that. That's easy. What's 9 divided by 3? It's -3, so we put a minus there. Now, what did this question ask? This question asked to find what? The slope and the y-intercept. It didn't say just give me an equation of a line, but we put it into an equation of a line so that we could find it. Remember what I said just a few minutes ago? Are you able to now to just look at it and pick out which one is the slope and which one is the y-intercept? Yes, you can. Okay, that's why we use the slope-intercept form, because it has a slope right in front of us. It's got a y-intercept right in front of us. So now I can pick it out. So what is the slope? What is the slope? Yeah, you could put 2 over negative 3 or just negative 2/3. It's the same exact thing. All right. And now can I find the y-intercept just by looking at it? Sure. The y-intercept is what? It's negative 3. That's right. So that is the answer. Make sense? Yeah. All right. Your homework. Now we're ready to do 2, 3B. Remember, we're like a day behind now because we took too long yesterday going over the homework problems. So this is actually it's on Tuesday's day on the lesson plan. So it's 2, 3B, and it's pages 122, 123, and it's 25 to 44. All right, that's your homework. That is due tomorrow, which is Thursday. All right, that's all I got.